let's begin with Zostera morphology. Every time a leaf falls off, it leaves a node on the rhizome. These nodes are swelling and also have root hairs that come off of them. Sometimes at a node there is also a branch where there's been asexual reproduction. Here's an example. This node has a branch coming off. You can tell this is a separate shoot because it's completely enclosed by its own leaf sheath. On this plant, there's also a branch at the next node. Here's the next node, and this node has a leaf that's coming off on this side. Here is the leaf that comes off from the previous node. It goes all the way down there. But at the next node, and you can see it right here as we take off that leaf, that outer leaf, you can see a new branch that has started right here from this node. And you can see an incipient node obviously still has a long way to go before it's fully expanded, but an incipient node from the subsequent leaf that will be coming off on this side next. Okay, so as we, that branch just came off. So as we work up to understand the morphology of the main shoot, which is coming off of the end of the rhizome, here's what we can see. We can see here the oldest leaf that is still on this plant, and the leaf sheath that wraps around all of the leaves. So there's the line on this side, and here on this side you can see the leaf sheath goes all the way up to here. When I pull this leaf off, you can see the leaf sheath splits at the sides, but previously wrapped around all of the leaves. That's the oldest leaf. The next oldest leaf has come off on the opposite side of the plant and has a leaf sheath that extends all the way to here. This leaf. The next oldest leaf will come off on the other side of the plant and has a leaf sheath that extends even farther. And that's very typical of Zostera during its main growing season, as the plant is both getting larger and also, of course, each subsequent leaf comes off slightly farther along the rhizome as well. So there's the leaf sheath for this third oldest leaf. The fourth oldest leaf also, you can see, has extended its leaf sheath a little bit farther up. So here's that one. Now we're down to the three youngest leaves. These are very green, rather thin, and the leaf sheath for these leaves are all still expanding, and so they remain within the leaf sheath of these older leaves. But here's our third to youngest, quite long, but still growing a little bit. Second to youngest, definitely still extending. And our youngest leaf, right here, that will continue to extend. So one of the key things that will be measured for morphology on each plant, just to give an indication of the size of the plant, has to do with the length and the width of the leaf sheath. And this is tricky, of course, because there are a lot of leaf sheaths that could possibly be measured. And for standard procedure, I think the best thing to do is find the node, the most recent node, and then find the leaf, the node that you can see, so that's just where the incipient roots are coming off, and then find the leaf sheath that connects to that node and measure that for the length of the leaf sheath. So it won't be the longest possibility, but it will be the leaf sheath for which you can see the entire distance. And that leaf will be on the same side as the two spots where the roots are coming off. Okay, when you mark a shoot, I'm going to actually mark it on a different leaf sheath just to make this point very dramatically. When you mark a shoot, you can essentially choose any leaf sheath, not the youngest ones though, because those will continue to expand. But you can choose a leaf sheath, and then also make sure that you mark any leaves, older leaves, that are on the opposite side, and you mark it. So here I'm choosing this leaf sheath here, and I'm also making sure if there's a leaf on the opposite side that I will mark it as well. So taking the marking device, poke 2 holes through. That will be more challenging if the plant is not more than 1 centimeter wide. But that will mean that there's a mark in this leaf that will be possible to see, potentially, if that leaf is still on there, and also a mark in this leaf sheath, which is likely still to be there after a week or 2 weeks. And always, when you return to these plants, make sure that you find the mark that is most proximal to the node, because that, whether that's in a leaf sheath or in a leaf, that's going to be your best indication of where it was originally marked. Okay, so I'm going to now turn to a shoot that has been marked. Make sure I'm getting the right one. There we go. All right. So this shoot has been marked, and the first thing, just to practice, is to make sure that we are getting the leaf sheath and the leaf length. And I can tell that the leaf has been marked because I can see 2 holes, and actually these holes are both on this leaf and also on the leaf sheath, which is connected to the next younger leaf. There's 2 holes there as well. And for sheath length, oftentimes this sheath actually is going to be the one that you will be able to see the node for. In this case, the roots are on the same side as this leaf sheath, and so that's going to be the leaf sheath length. Here it's 25 centimeters, and the sheath width, which is done to the nearest ½ centimeter, is 11.5. Sorry, ½ millimeter. 11.5. And this is a really great example of a case where the shoot has branched recently. Again, you can see that this set of leaves, they're much narrower. That's an indication that it's a branch. And also they're all contained in their own leaf sheath. And then they have this leaf sheath from the original plant, which is on the outside of them. And the branching happens within that leaf axil. Okay, so to process this sample, we'll actually want to include the branch as well. And then we'll cut the sample at that original mark, so that we can look for leaf extension beyond that mark. And then the tricky part, especially since it's a little windy right here for light, is to peel these leaves apart in the order that they've been, that they're layered on here. So here's one of the oldest leaves on this side of the plant. Next comes a younger leaf, and I'm having to actually break the leaf sheath in order to peel that off. But you could see this one has actually grown, so the marks are right there. This one has grown a couple of centimeters. So it was quite far extended when the plant was originally marked, but this leaf was young enough that has extended a little bit. Then as I take off the next one, I'm also going to break off the leaf sheath. So I pull this out of the leaf sheath. You can see these leaves are getting much greener, which is a good indication that they're younger leaves. And this one has grown all the way up to the 2 marks right here. So it was much shorter when it was originally marked. And then I see there's a tiny little bit. That's the youngest leaf right there. Obviously unmarked, and it's just beginning to extend. So this on the data sheet will be leaf 0. This is, remember, these leaves come off on opposite sides, each subsequent leaf comes off on opposite sides. And so here we have the youngest leaf, and now we can identify this is the next youngest leaf because it has not extended its full amount. It's still extending, and it's not marked anywhere along there. So both this smallest leaf is a leaf 0, and this larger leaf is a leaf 0. They were not marked and have appeared above the mark since the time of marking. So this will help us indicate the plastocrine interval, how frequently leaves are actually formed. Okay, so now I'm pulling off the next leaf, and this leaf again is an older one. We can start indicating them now since this is leaf 0, leaf 0. Here's leaf 1, which has extended the farthest amount. Leaf 2 extended to here. This is leaf 3. We already indicated that it extended to here. Leaf 4, I'm bringing in now. Leaf 4 did not extend at all. And then beyond leaf 4 is where we're actually picking up, in this case, a new branch. You can again see these are all very small leaves, small both in terms of length and in terms of width, and they are all a similar size. So they appear in the same relative place, and so they belong to the same branch. Sometimes you'll just see a single leaf from a branch. Sometimes you'll see up to 2. Okay, so once again, we have leaf 0, leaf 0, leaf 1, which has extended to here, leaf 2, extended to here, leaf 3, extended to here, leaf 4, 0 new growth, and it also has a damaged tip. Leaf 5 did not grow, so 0 new growth and has a damaged tip. And then this branch, in this case, we would say it actually came off at the leaf axil of leaf 6, even though leaf 6 is not present. The location of this branch is between leaf 4 and leaf 6, so we say it came off in the axil of leaf 6. And then just to show you the measurements, on leaf 0, we have a new growth of 1.5 centimeters. On leaf 0, the next one, we have new growth 49 centimeters. On leaf 1, we have new growth of 55 centimeters, and the original size (42 centimeters). Leaf 2, new growth of 19.5 centimeters, and the original length, let's see if any of the rest of the site can match things like this. The original length, 97 centimeters with an intact tip. Alright, leaf 3, 5 centimeters and new growth, original length, 97 centimeters with a broken tip. Leaf 4, 0 new growth, original 68 centimeters with a broken tip. Leaf 5, 0 new growth, 33 centimeters with a broken tip. And that will complete the measurements. I guess actually we need to measure this branch. So this branch will come in at leaf 6, and the maximum length, 20.5 centimeters. And it was not marked, so it has shown up in the intervening time beyond that mark. And with that, that completes morphology and growth measurements.